Graphing a system of two linear inequalities. Graph the solution to the following system of inequalities. 7x plus 3y greater than negative 6. Negative 4x plus 5y greater than or equal to 10. Then give the coordinates of one point in the solution set. First thing you want to do here is actually graph the lines. And there's going to be a dotted line and a solid line indicated by a symbol. The greater than symbol without the equal sign is going to resemble a dotted line here. The dotted line is represented by 7x plus 3y is equal to negative 6. This other symbol here, greater than or equal to, because it has the ability to be equal, this is going to be graphed as a solid line. And the solid aspect is actually going to indicate that those ordered pairs are going to be shaded as well. What is that solid line going to be? Negative 4x plus 5y is equal to 10. I'm going to go ahead and use the intercept method to graph these lines. So the red line here, I'm just going to make a t-chart. X and y. And when x is 0, we can see that y must be negative 2. And when y is 0, we could see that x has to be what? Negative 6/7. We're going to need at least two ordered pairs to graph the other line, negative 4x plus 5y equals 10. Once again, I'm just going to indicate the ordered pairs with a t-chart. When x is 0, y must be 2. And when y is 0, what does x have to be? X is 10 over negative 4, or 5 over negative 2. Now we are ready to graph our dotted line and our solid line. And if you have graph paper and a straight edge, that would be very, very handy. Just remember when you graph those lines, make sure you cross the x and y axes. Draw those lines. Another thing you want to remember when you're drawing these lines is to put the arrows at the end so that it matches the domain and range of these functions later on. Okay, it's very important that you have these arrows at the end. Now we're not done yet. We're trying to solve this inequality by graphing. And what we want to do now is pick a test point. And a test point, a good test point would be a point that is not on either one of these lines. A convenient one here would actually be the origin. Notice the origin is not on either one of these lines. So what we're going to do is take the origin and test the original inequality. And this will tell us whether or not to shade the true side or the false side. Let's find out. So take 7x plus 3y is greater than negative 6. And we're going to test the origin. 7, 0, 0 plus 3 times 0, 0. Is this in fact greater than negative 6? Is 0 greater than negative 6? And the answer is true. So if this is true, that means we are going to shade 0, 0 relative to 7x plus 3y greater than negative 6. Remember, that is represented by the dotted red line. So if we are going to shade 0, 0, I'm just going to draw a little arrow there tell me that I'm shading towards 0, 0. And I need an arrow on this side as well. Let's test the other inequality. The other inequality is negative 4x plus 5y is greater than or equal to 10. Notice 0, 0 is not on this blue line, so we're going to use 0, 0 again to conveniently test whether it's true or false. Is 0 greater than or equal to 10? This time it's false. So what does that mean? From the solid blue line, we do not want to shade 0, 0. In fact, we want to shade away from it. So I'm going to indicate it here with a little black arrow. Right there is a little black arrow here saying don't shade the 0, 0 side. Now, where the intersection occurs is going to be a solution to this system of inequalities. That intersection is actually occurring right here. So if I extended these black lines where I need to shade up here, and it keeps going forever, you're shading forever. And then over here, there's these yellow lines that says I need to shade over here as well. So that's why I just draw the little arrows at the end to help me keep track. So I just draw these little arrows here at the end. And wherever the two colors intersect, or wherever the shading intersects, that's going to be the solution to your system. Alright, to answer the very last part, it says then give the coordinates of one point in the solution set. Well, there's lots of points. You could point to one right here. That one would certainly work. But it makes sense to just pick something, a little bit more obvious. Maybe this one's obvious for you because the solid blue line says it is shaded here. So this ordered pair would work. 0, 2 would be a solution. But just for variety, I'm going to pick something else. I'm going to pick, I'm going to note that, let's say 1, 6,437 is a solution. In other words, that ordered pair is shaded. Okay, it lies in the true region for both inequalities. Now let's circle your answer, and you might as well circle your work. You do want to justify your answer, so it's very important that you actually indicate your test point. So for both lines here, we did use a test point of the 0, 0, and that will work. So let's recap this. The first thing you did was you drew the lines, and you had to indicate which one's dotted and which one's solid. Then you have to shade each inequality and just make the shading be noted by a little arrow. And where the shading overlaps turns out to be the solution to the entire system. So why don't we circle everything? Why don't we circle what's needed as justification? Make sure you shade your work with the test point. Make sure your graph is really, really nice and neat. And then, of course, you also needed to do the second part of this question, and that is to state an ordered pair that is indeed a solution to the system of inequalities.